Great. So yeah, let's get started. So first of all, we're going to talk a little bit about Tauri, which has anyone here have heard about Tauri before? Cool. So to the ones of you who haven't heard, we're going to talk a little bit further onto that, but there's going to be some Rust language involved. And so to the ones of you who, as I am, are often a little bit scared of Rust, I brought Nova here. So if at any point some scary Rust code shows up, you can focus on her and it's going to go away soon, I promise. But yeah, before that, who am I? As Daniel already said, I don't want to mess up with what he said because it was better than what I can say for myself. A developer relations lead at this company called Crab Nebula. I work with a Solid.js developer experience team, and I am a GDE for web technologies. Because naming things in the web is hard, I put like these nice shortcuts on my own website, so you can find me anywhere. Just appending the social media name to this to my own domain. And so yeah, we have quite a few stuff to talk about, so let's get started, right? So first of all, as I mentioned, Tauri is a framework for building hybrid apps, hybrid and native. There is a use case for building native apps, but essentially hybrid apps, and it is powered by Rust. So what I mean by that is, first of all, this on V1, which is the one we have today, we can build desktop apps. We can build for macOS, we can build for Windows, and we can build for Linux. And then on V2, which is right now very close to reach a release candidate mode, so the APIs are quite stable. It's about to, like, we are very close to have a stable release. It's on the security checks. On top of the ones you can already build, you can already create binaries for Android and iOS. But yeah, but how does Tauri accomplishes that? Tauri, as I mentioned, is based on Rust. So it has two main components. The first one being the native window management system, which we call Tau. And it's built on Rust, and that's the part that makes the connections with the system calls. So you can actually write native code with Rust. And then it wraps the native web view. And with that, because you're writing on a web view, you can use whatever web framework you want. So basically, you can take any single-page application app, or even like any web app, actually, and you can wrap it into the Tauri web view, and that allows you to ship it to create binaries for all of those different platforms I mentioned before. But what's the deal with that? There's so many other frameworks that already do it. The first thing that people notice, besides the speed of Rust and the security of Rust, and these things that Rust empowers, being the backend language for us, is that, as I mentioned, it wraps the native web view, and it connects to and it allows you to write native code, which means your app is as big as your bundle. And when I say that, I can say, like, for this little example of mine, where I already shipped it here. Can you see this? Yeah, so as you can see here, I have here like the binaries for each one of the desktop apps that are possible. And this is the size of my app for the Apple Silicon. You'll see that the Apple Intel ships the universe with it. But then again, you have like the Windows, and you have the Linux ones that are like 3 megabytes and 2 megabytes. So that's a huge vantage point for people that are coming to Tauri. They realize that it can actually ship very fast, secure, and performant apps. So that's why I find it so interesting. And we'll talk about Pulsar in a little bit more. This is actually a demo app that I wrote because I wanted to learn Tauri. So I jumped into it with a JavaScript mindset because I'm a JavaScript developer. I'm not a Rust developer. which leads me straight to addressing the elephant in the room. Tauri is great, but do I need to write Rust for it? Do I have there are people that are Rust enthusiasts here, or are you confident with Rust? Or yeah, me neither. So the thing is, you actually can. So you can actually write Tauri apps without Rust. I actually use Tauri to learn Rust. So I can get pretty far writing JavaScript with Tauri. And then when I actually need to do more stuff, or when I want to do more stuff, I can now jump to Tauri. So I can jump to the Rust backend and do other stuff. That's what I did with Pulsar. So for example, Tauri is going to expose a set of APIs that you can communicate directly to the system from JavaScript. So these are type-safe APIs in TypeScript that you know exactly what the system is gonna give back to you, and then you can do it. On V1, if you were familiar with Tauri before, this was a much longer list. For V2, they're actually split now, so you also have plugins where you can then connect and use. So we have way more stuff than we had on V1 now, but they are separated for making it easier for you to deal with it, and also because when we bring mobile to the story, there are a lot of APIs that are available somewhere and they're not available somewhere else. So then you can actually be able to manage those kind of things. But yeah, as I mentioned before, if we're learning, we got to be able to debug, right? So unfortunately, to this point, Rust is not quite like JavaScript in terms of you cannot console log stuff where you want. You cannot impact the runtime and so on. So that leads to the first integration tool that I use to learn Rust and to learn Tauri. That is a tool that I actually work on, so it's a little bit of dogfooding for me because we created this tool called DevTools that's essentially supposed to be what Chrome DevTools is, but for a Tauri app. And the way it works is actually, I have here my code base. So let me, this looks horrible. Okay, so let me just change. Oh, that's very bright, sorry. Do I have something else? Pesto? No, I don't. Sorry, let's deal with that. Okay, so it's gonna be short. So what we can do with this is essentially like, a Tauri code base is essentially like any other JavaScript code base. You have the source, and as you can see here, I have this is actually, sorry for the logo, this is not a React app, this is a solid app. But you can have your JavaScript app as it is. This essentially can, to be honest, it actually compiles with the Vite. I have my Vite config right here. There are a few specific configurations that I like. I lock the door for the port for my dev server, and I make it break if it's not there because Tauri is going to be listening to a specific port. I have some inf prefixes that are for Tauri, but other than that, it's just a regular Vite app. And then the magic starts happening on my source dash Tauri. So in this case, you can set up your stuff over here, and then in the main, what I wanted to show you is actually in my lib one, where I can connect my DevTools, just like that. And this is a little bit more complicated because I put here a conditional clause because I only want my DevTools to be plugged in when I'm on dev mode, because I want my binaries to be small and my users don't need to debug my app for me. So yeah, essentially I'm just connecting to the builder and I'm adding my DevTools plugin, which allows me to then come over here and say pnpm Tauri dev, and once I run, it's gonna compile. Hopefully, so it starts the Vite server and then it compiles the app. It should be fast because I compiled a little bit earlier. Because yeah, the first build can take a little bit longer with Rust. And then, okay, once it's done, I have my app here. But what I wanted to show you about the DevTools is that the DevTools actually exposes to me this little URL. And then if I come and click in this URL, it actually opens my app over here. And then I have my console tab. I can actually debug the calls that happen to my system. I can debug my config, and I can check like which are the attributes that I set, and what do they mean, so what is a CSP in this case, and how do I do it, and so on, and where is this entry in the docs, and etc. So let me see if I can I think I need to do this. Okay, so now I'm in the full screen, whatever, yeah, and what I wanted to show you is that it's actually connected live to my app. So basically, as I move my window, you can see the logs coming up, and we can actually do some scanning here, because that's what my app does. So this app is supposed to scan all my node modules recursively, go deep into them, measure the size of each file, sum it up, sort, and bring it back. I have a few big repositories here, so it's going to take a little while. But essentially, this is what's going on in this case. And then you can sort the attributes. You can see that the call was thrown. And then I have my glob regex. The number of the directories came up. So I have 174 directories, the same one as I saw here. And then I have all my node modules per size. And then there's one that I don't want to do it. I don't need to work on it anymore. And then I can just come here and delete with the native APIs. So that's essentially what Tauri is. And now I can close it up. As I close, it realized that my connection was broken. And that's it. So this is the first one. So with this, as you can see, we can then start debugging as you would. So I can log stuff to my console, or something close to my console at least, with the DevTools. And that's cool and all. But then, once we debug, once we learn, we want to ship our app, we need to optimize. And then again, I'm not a Rust developer. But I talked to Rust developers, I read docs, and basically you can go to your cargo toml and you can define a profile release. So that's what I did. So I set all this weird stuff that doesn't mean anything to me. And then I know that the panic abort means that I'm going to strip expensive panic cleanup logic, which means that on dev mode, what Rust compiler is going to do is have some additional information for wherever your program panics to let you know why that panic was caused. You don't need that in production. Then you can actually make your compilation time sequential. So what Rust does is essentially grabs all your dependencies, compiles all the dependencies, and adds to your build. So with this code gen units, you set it to 1. It makes sure that it's going to compile one dependency at a time. So that allows you to optimize for a smaller build optimization. It can make your CI takes a little bit longer, but it pays off on the binary. So that's a metric that you can play with. Then you have this LTO true, which allows some link optimizations between your dependencies and your code. Finally, there's this requires some fine tuning, but in a general manner, if you add the opt level S, it means you're going to optimize for binary size. In some specific cases, they're not that common. You're going to see your build times going a little bit too high. So if you have a big Tauri app, you might want to check that. That would be the first one you would look. And finally, this, I think, becomes default in Rust in some new versions, but I'm not sure. But then the strip goes through. It means you're going to remove a bunch of debug statements from your build profile. Then again, because you're saying profile release, that's essentially your prod build in JavaScript language, I guess. But then again, OK, so you wrote your app. You got as far as you could with the API configs that Tauri exposes. You got something working. You know your app is looking good. And now you feel brave, right? You want to go there and dive into Rust and do something with Rust. So for that, we can actually do some optimizations for our performance. One of them is this, my favorite one is actually this package, this crate, actually, from some friends of mine. That's called Tauri Specta. So Specta is another crate that's going to generate TypeScript types out of Rust commands and methods. Tauri Specta is the wrapper for Tauri of that Specta. So both are maintained by the same people. essentially what happens is you have your Rust command, and then there's one command that you actually want to expose to your TypeScript runtime for it to be able to invoke straight from there. What's going to happen is that on compile time, Specta is going to generate the types for you, and then it's going to expose, generate a new file, TS file, that's going to expose the commands object, and that commands are going to have all the keys of the commands you exposed. In practice, what it looks like in V2 is like this. Then again, this is Rust code. I don't expect anybody to look at this and make sense of it. At least, yeah, it takes a breather. But what I want you to look at is these parts. So you're going to take an array of your commands, and then you're going to define which path those commands are going to show up. And then once it does, it's going to look like this. So the commands is going to give you this get dir data, which is the camel case version of the snake case name. And it's going to give you a promise with a result. And then result is kind of a translation from what Rust is. As you know, Rust demands that you deal with errors. So if you can see this result here, it's either going to be a success or an error, which means that then we have a status OK with the data that's going to be the result of your actual invocation, or an error, and then it's going to be one of the errors you treated. So yeah, essentially that's how it goes. So with this, if we jump into my code base again, I can show you this part, because there is no system API to check all your node modules, so I had to write it and then expose it to my JavaScript. So what we did is essentially, no, that's not what not this, here. So we have this get directory data, and this get directory data, as you can see, it's going to bring back exactly the type that Tauri Specta created for me in TypeScript. So it's going to give me my folder stats, vec. In TypeScript, vec goes in as an array as well, but yeah. And then the error. So then with this, I can either have, oops, yeah. So with this, I can either have an OK, which is going to be the status OK, that's going to bring me the folder stat with the path of the file and the size, or it's going to give me an error if it's not OK. Then I join everything, I order, and that's it. So this method gets exposed to my commands, and then it goes straight into my TypeScript bundle, and there you go. So it's exactly the same code written in 2 languages in this case. That's what Specta can do for us. OK, so that's it. We got some great DX. We know what we're doing, and we know what to build. The next step for us that never built like binaries, or never distributed, or never shipped to an app store, distributing can be quite hard. So to the point that you need to sign your app, you need to have certificates, and then the binaries, sometimes they're not so small as we saw. So in order to do that, you also need to integrate somewhere. You need to distribute somewhere. You don't want to handle all this logic. So this is actually the product for now is free in Crab Nebula. This is the one I'm using. I can release a distribution, and I can also set an auto update. So basically with this, I can create a GitHub action that looks roughly like this, and I'm going to pass my signing keys, and I pass the matrix of all the platforms I want to build for. I pass some other keys, like for the auto updater, I need to pass some extra keys and stuff, and that's going to handle it for me. So then with this GitHub action, every time I merge to main in my GitHub, it actually creates that release that I showed you before that has all the binaries that I want to have, and then I get a nice link that's distributed. But yeah, I've been talking for almost 20 minutes nonstop about things that you need to set up, right? Once I started doing that, I realized, okay, I don't want to do that again for every single app that I want to build, which is why I started doing this. So I grabbed all the nice things that I got, because I realized, because I'm working on a company that's very much Tauri focused, and I'm building a bunch of products that are Tauri focused. I'm going to create a bunch of sample apps, or I want to be able to create apps to do that. So as I start doing that, I mentioned, and some people let me know that they wanted it. So this is actually Quantum, my little template that's super, super opinionated, to be honest. But it just brings everything that I want to have in my app for me. It brings me the debugger, the dev tool for the debugger. It brings me Specta. It adds some Tailwind that doesn't come out from default on the Tauri templates. It uses Solid, creates the release profile, and set up the GitHub actions. So with that, I set up my GitHub repository. I start writing my code, and then I can ship to all the apps as I start merging to main. So, and I can show you how this works since we have a few more minutes. So essentially, you're going to have to believe me because I'm not going to clone the whole thing and npm install on a conference Wi-Fi. But let's see if I go to my app over here. So this is my Quantum repository, and then I can just go here and say, yeah, pnpm, Tauri, iOS, dev. And then as I run that, it's going to start compiling. It's going to ask me, OK, so which one of these iOS systems you want to do? I ran, yeah, the iPhone 15 simulator the last time, so it's already installed. This is all running with Xcode and stuff like that, so if it's not actually installed, you might have to download around 7 gigs or stuff like that of the device image. So that's why I'm using one that I already did. Once I do that, it starts building the app for us. A lot of stuff in the console. Takes a while. But once it does, you actually have the hot module replacement, as you would in any other JavaScript environment. So then it connected to the remote UI, which means it's then now going to start installing the app and archiving some app, and then the connection, and it's going to start the app, and then once it goes, it's going to come up over here. And deploying the app to the device. And once it's done, we have a JavaScript app, a Tauri app written in Java. So that allows me to then say something like this, and I can send it. And then this message goes to Rust, runs some native code, and brings it back. So we got an iOS app. And having the Android app is just the same thing. I can go Tauri, Android, dev. And then it's going to start the simulator again. This one's a little bit faster. That's why I left it for later. And then it loads, starts installing, runs the Vite server, bundle the app, and Pixel needs to wake up. So as you can see, it takes a little bit of time because there's a bunch of compiling stuff. It's actually compiling the thing and initializing the configuration and so on. And then once it's done, I said once it's done. OK. So yeah, as you can see, some of the builds, they're going to vary based on the platform you are in. The macOS is more or less the fastest. So then again, you can do the same thing. You can use the native one, the native keyboard, or your keyboard. And as you can see, this thing is not super nice. Yeah, but you get it. And then all the other ones, you can do the same thing, and that one is way, way faster because it's just using my native one and runs all of them. So this one we already saw before. And then you have the actual stuff. I need to finish this one. And this you also have the native app. So with the same code base, you can ship everywhere. And yeah, so that was what I had for you folks. I hope you have enjoyed it. And again, feel free to reach out to me on X or Twitter or YouTube, whatever you prefer. And thanks a lot.